Yes.
Yes.
Now there are only 9 person here, so I don't know why this morning a little bit people here. Maybe the first I will introduce yourself. My name is thuyết, and okay, I have many years teaching in Department of Mathematics, College of Education here University. I think that it is about near 45 years, maybe. Yes. So of course, I over 60, mean that the year that I can stop working. However, I continue to work here by the request of the university. Okay, so I think that everything related to our course, I write very detailed in that I sent to you. So I think that you can read and then follow it. It's, we have a 2 chapter to follow in this course. The first is module and the second is algebra. And I think that the module should be studied carefully because we can follow the algebra. That is the same method with the module, but that is some different. But the important is should be carefully reading the module, and then we can follow the algebra very easily. Okay, so we will study the module carefully. That is something that I would like to introduce myself. So I think that I request you one by one, and I will call here is in the here, and then you can open the camera and introduce yourself. Okay. So you can introduce the name. How are you? Place of birth and where do you live now? Something like this. Okay. And if you have anything difficulty in studying, you can say now. We take about 15 minutes to introduce ourselves. Okay. So the first is Nguyễn Khánh Trinh. Open camera and introduce yourself.
Hello, teacher. My name is Jane. I'm a leader of the class. I'm from Doha City. I'm very friendly now with you.
Okay, and now you stay in Hue or in Đông Hà now?
Yeah, I'm at home.
Oh, at home, okay. I don't know where we will study on the class because in the information from the college from the university, they say that if we will go to the class, they will have the information for us. So I don't know where, but the first and maybe the second weeks maybe to study online. I don't know. Okay. Thank you, Trinh.
Yeah.
Next, Minh. Trần Minh.
Yes, hello teacher. My full name is Trần Nhật Minh. I live in Quảng Ngãi City. I got something to tell you that this morning someone in our class had to take a test from the all the course, so they asked me to be absent from this lesson this morning.
Okay. Thank you. Thank you. Okay. The next is Bảo Trâm.
Hello, teacher. My name is Hồng Bảo Trâm. I live in Đức Trọng, Lâm Đồng.
Lâm Đồng?
Yes.
Okay. Someone else? Okay. Continue.
No.
Okay. Thank you. Thanh Ngân, Võ Thị Thanh Ngân.
Hello, teacher. I'm 21 years old and I live in Korea.
I don't hear anything. Again? Ngân?
Hello, everyone. My name is Thanh Ngân. I'm 21 years old and I live in Phú Yên.
Phú Yên. Okay. Thank you. Ngọc Phương.
Hello everybody. My name is Phương, Trần Thị Ngọc Phương. And I come from Kon Tum.
Kon Tum. Oh.
Yes.
Our class from too many provinces.
Yes.
Phương. Okay. Thank you. Thu Thảo.
Hello, teacher.
Open camera. Okay.
My name is Thu Thảo. I'm 22 years old, and I come from Đông Hà, Quảng Trị.
Oh. Thank you. Thu Thảo, Đông Hà. Yes, Thu Thảo. I don't see your list here. Thu Thảo.
Dạ thầy ơi, em mới đăng ký học cải thiện nên là chưa cập nhật chính sách đó thầy.
Oh, yes.
Dạ.
What is your full name?
Dạ, Võ Thu Thảo.
Okay, Võ Thu Thảo. Thank you. Phạm Ngọc Hưng. Phạm Ngọc Hưng or Phạm. Here is Phạm Ngọc Hưng. Here is a Phạm Hưng Quân. What is Phạm Ngọc Hưng? Okay, I don't see here. Oh, the list is quite different. Okay, Phạm. Oh yes, I see here. Thank you. Where do you come from? You are in Huế now. Okay. Thank you. Bảo, Phong Bảo.
Hi everybody. My full name is Huỳnh Diệm Phong Bảo. I come from Tuy Hòa City, Phú Yên province. I'm a final year student of the university. The reason I'm taking this class is that I found abstract algebra. Try. My goal is to get high mark in this subject this semester. Thank you everyone for listening.
Okay. I know, because you are very familiar. I read your name many times. I don't remember, but however, I remember that you already study.
Yeah.
Okay.
I'm already
Yes.
study.
Okay. Anh Thư or Thư Anh? Anh Thư.
Good morning, teacher. My name is Anh Thư, and my full name is Ngô Thiện Thư. Like you have great. At 20 or at 21st February. This is also my birthday, and I was in 20. I'm originally from Huế City too. Yeah, and nice to meet you today.
Okay, thank you.
Yeah.
Thank you, anh Thư. Ngọc Khanh.
Hello, teacher. My name is Khanh. I'm come from Gia Lai.
Gia Lai? Khanh? Maybe a new one here. I don't see your name here.
My full name is Đinh Ngọc Khanh.
Đinh Ngọc Khanh.
Yeah.
Okay, Đinh Ngọc Khanh. I don't see the list here. Okay, so you come from Gia Lai?
Yes.
Okay, thank you. So all here, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I send you all the documents related to our course, and you remember that that is the book, the main books that we will use in this course. You remember to down the file and then print it. So when I teach, you can open and see here, and all the exercise homework is here. Okay, that is a very new one, because I and Associate Professor Trương Công Quynh have written, and then we have not enough time to publish. But I think that in this year I will publish it in the Huế University. Okay, so you remember to print it. Okay, so I will use the Okay, now do you see the whiteboard now?
Yes.
Okay, so I will teach in this whiteboard. Okay. The module here is one of very important structure of algebra. You have already studied group, ring, vector space, few or something, many structure. So here's the module here is another structure that we should research, and then you should fry it, and you should study it. I begin with you remember in the abstract algebra 1, you study group, And then from the group, you can study the abelian group. Okay, I say the abelian group. Abelian group. The abelian group here, you remember, for example, that is, we can write that is the and for example, you can take the operation is a plus, and then satisfy the condition one is associative, mean that for every x, y, z in J, you have the x plus y plus z is equal to the x plus y plus z. Okay. Abelian group, so that is x plus y is equal to the y plus x. And the first is there exists we denote by 0 in J, so that for every x in J, you have the x plus 0 is equal to x. And for every x in J, there is minus x in J, so that the x plus minus x is equal to 0. Okay. The abelian, you have 4 axioms. The first is associative, commutative, or something like that. Okay. So from the abelian group, you remember that is very basics knowledge, and we construct from this we construct the vector space. Okay, do you remember the vector space in linear algebra? Vector space. So the vector space we can write because V, okay, V, because that is a vector, so we can write that is a V. And the V should be over the field K. Hey, yeah. K is a field. You remember that is a field. Should be a field. And then the basic is the abelian group, mean that the VK should be, and then, okay, of course, that is the plus, should be the abelian group. I write the abelian group here, okay? Briefly, okay. And the next is, should be satisfy more axiom, mean that I will write more false axiom. That is the first x, y in V, and for every k in K, k in K, so you have x plus y, and then to tie with K is equal to the xk plus yk. I would like to say that mean that's more than more operation, mean that here is a V and K, so you have the operation is what is this? What is the xk? Here is xk here. Mean that you have the operation x here and then tie k. Here is the plus, mean that you have the x and then plus y for x, y in V, and here is x and k. So you have the first, and the second is okay, for every x in V, for every k1, k2 in K, and then you have the x, and then k1 plus k2 is equal to the xk1 plus xk2. And the first is something like this, but the xk1, k2 is equal to the xk1, k2. And then the open here is here is k1, and here is k1, k2 here. Okay. And the last is for every x in V, you have the x1 is equal to x. Okay, so that is a 4 axiom, and then you plus 4 axiom, so you have the vector space. That is a vector space. And then you can remember that is to call vector, because you remember that is on the model is vector, mean that okay, you have here is one vector and another vector here, and then the plus is here, that is the x plus y. And the x here, and then if you tie with the t, and then it will be here is the xt. If t bigger than 1 here, and if t is 0 to 1, that is will be here, maybe here, and then it will be something like this if t is lesser than 0. Okay, so you remember the model of the vector space is here, and the case in this case is equal to r, mean that the real number. Okay, so that is the real number. Okay, the abelian group, you construct the vector space, and from the abelian group you construct the rings with identity. The ring with identity. Okay, what is the ring with identity? The ring with identity means that the abelian group here, for example, we say that the ring R, so that is two operation is x plus y, and the second is x multiplication x y here. Okay, we have a two operation, and then the ring with identity means that we should have a 4 more axiom. Okay, here is the abelian group, mean that the R and then plus is abelian group. Okay, and the second is you have something like this, but that is here is K, but in this K you will have here is not K, but that is X, Y, and Z, mean that X and then Y and Z here is equal to the XZ plus YZ. Here is K1, K2, but in this case that is all in R, so that is K1, K2 is X here, and then Y and then Z here is equal to, similar with this, but you change that is X, Y, and plus X, XZ. And the same here is associative, mean that the X, Y, Z is equal to the X, Y, Z. And the last one is X1 is equal to the X and equal to the 1X. Here is identity. This is identity here. Okay, so I introduce here, and then now I cannot say more detail about the abelian group, about the vector space, about the rings with identity. So you should read again carefully, because we will apply this structure to module. Okay, you remember to read it carefully. The vector space, the rings identity, and that is based on the abelian group. Okay, now we introduce the module. We introduce the module. From, you remember that the abelian group is the base for this one. And then that is also the base for module. I mean that is very important here. And then now from this, you construct the module. The module is, we can say briefly, that is, I will replace K is a few here by a ring with identity. I replace K here by this one. So the VK will be right, because that is module, so I will write M and then R here. To replace here K by R. That is only to replace K by R, and then it will change. To change many things should be changed. Mean that, okay, mean that the MR is an abelian group here, the abelian group here. Here is a V. Now we change the name is M, mean that the M and then the plus is abelian group. Okay. And then that is also have the operation. And then we will say that the module multiplication. Module multiplication. Here is the plus, and now is the module multiplication. Multiplication. Here is M and then tie with R to M. And then here is M and here is R, and then I will receive the MR. Okay? The MR. The MR. M in M and R in R. And then we tie M is with R. It will be the element belong to M. Okay? So satisfy the condition here. The same vector space. That is only to replace K by R. K by R here. Mean that you replace here is by R. Here, okay. Maybe I will erase here because the abelian group is very familiar to you, so I erase, and we will. Okay. So, okay, here. Mean that, okay, satisfy the condition here. The same, I will write here for every X, Y in M, for every R in R. Okay, that is only to replace K here by R here. And then here is the X plus Y and R is equal to the XR plus YR. The second is also the same, mean that you have for every X in M, for every R1 and R2 in R, so you will receive the X. So here is R1 plus R2 is equal to the XR1 plus XR2, okay? And then for every here, you receive the X. Then here is R1, and then R2 here is equal to the X R1, R2. And the last one is for every X in M, you receive the X1 is equal to X. You see that that is the same, but that is only different. Here is K and here is R here. K is I. That is different. So we will call, when you change the K from the few to the ring with identity here, you will receive the structural module here. Mean that the module MR here. Okay, that is the first different from vector space, and the second is module. But the second is here. The second is because the ring with identity here is don't say anything about the commutative. So we will call M here is, we will call M is array. You remember that is array R module. Denote by here. Denoted by. Denoted by. By here, okay. Denoted by. So you have right because you will have a left. You will have a left. And then what is the left R module? The left R module is defined by, okay, the first is M is the abelian group, the same. The second, the multiplication is to change from the right to the left. Okay, I will change here, okay, now. Here is, I will write here is R, and then tie M here. And then the multiplication is R here and then M here, and then you will receive the R tie M. Mean that you ties with the M in the left, R tie M, but the R is in the left. In the left. And then, of course, the axiom should be changed. Change from the right to the left. Mean that, okay, I will change here for every X, Y in M, for every I in R, and then you write R here. Okay? And then you, sorry, here is here, and then, okay, that is equal to Rx, and then Ry. Plus Ry. Okay. The second is, okay, the X is here. Okay. Maybe I will write this. Okay. Yeah. Okay, X here. You write X here. Is equal to R1X plus R1X here, R2X here. And then you change the same. The X is in this. In it here. Okay, I will erase this on. Okay. This, okay. And then here is X. X is okay, X is here. And then R1, R2 here is equal to R1 and then R2X. And then here is 1X. Okay. And then in this case, we will call that is the M is a left R module, left. And you denote by M, and then R is right in the left. Okay. In the left, okay. In the left. Now it will arise some question. some question. Okay, I will write the question here. The question one. The question one is, if you have the MR, okay, if you have MR, mean that the full rise is if you have a right R module. Okay, I will to write here. If you have the MR here. Okay. The question is, then can you create RM? The question two. The question two is, what is the reason why you don't call the vector space right space or left vector space? The right vector space, the left vector space. Why you don't call the right vector space or you don't call the left vector space? What is the reason why? Here is a two question. However, if you solve the question one, and then it will be solve the question two. So I will solve the question one. The question one is, if you have the structure of MR, and then you can create the structure of RM, mean that the left R module M. So you can see in the definition, the same is the abelian group that is not changed. Mean that the left the module and the right R module is the same. Okay, that is the same is here. The M is the abelian group is the same. So for the abelian group, we don't say about the left or the right. Okay, that is the same. The difference is the module multiplication. So, okay, if you have the right R module, mean that you have a, I don't know where I can write it. Okay. Okay, maybe we should erase the vector space. Okay, maybe we should erase. That is very small, so we don't know. Okay, so you have an MR. Okay, M XR or MR. Okay, you have this one, the X. That is you have this one, XR. And then we would like to have the left multiplication. Mean that, for example, I write that is R, for example, star X. Okay, that is, you have this one, but you don't have this. And then we should define this. We define this is equal to what is? Define that is equal to the XR. Define XR. And then we should check is satisfy this one, this one, this one, this one or not. Okay, you can take you can check this one, and this one is okay. That is right. So you check at home. I don't check here. I would like to check this one. This one. This one and this one is are right, but you should check this one. Now I check this. You write. Okay. You remember that is the new operation here is star. So you write here is R1, R2, and then star, X. And then here is the right side is R1, and then star, R2, star, X. And we should prove this is equal to. So I write this is equal to, here is the star mean that to change the sign, mean that is equal to the X, R1, R2. And then that is equal to, okay, that is equal to the X, R1, R2. But this side, the first is R2 will here, mean that X, R2, and mean that R1 is here, star. And then that is equal to the X, R2 and R1 is here, okay? And then that is equal to the X, R2, R1. Okay, so who can answer me? You can see here, and then you can say to me that what is the condition for this is equal to this one. Okay, who can answer me? The question here, when we will have the equality here? Who can answer me?
I think it's when it's commutative.
Yes. When the ring R is commutative and then R1, because that is all the white ball here. Who have us answer me?
Minh, Trần Nhật Minh.
Trần Nhật Minh, okay. Thank you, Minh. So in the ring is commutative, and then R1, R2 is equal to R1, R2, R1. Okay, and then here, okay, that is equal here. Okay, so when the ring R is commutative, and then R1, R2 is equal to R2, R1, and then this is equal, and then R1, R2 star X is equal to the R1, R2 X. So the ring R should be commutative. So if the ring R is commutative, you have the right arm module, and then you will have the left arm module. And the structure is the same, because you can see the operation here only to change the sign. Here is the Rx and here is XR. It's the same. Now we write Rx, need not to star or something like this. Okay? So in this case, Rx is equal, if the commutative, and then XR is equal to the Rx. Here, need not to write it. Okay, so the first conclusion is, if the ring R is commutative, and then you have the right arm module, you will have the left arm module, and you have the left arm module, you will have the right arm module, and that is the same. In this case, so okay, I answer the question 1 is the answer here. Answer the question 1. answer here. The question one is, if you have, then, okay, if, okay, over here, so I write that if R is commutative, is a commutative rings, then MR, we have a, okay, I will write yes, and if you have MR here, you will have MR here. And in this case, you will call the R module. Need not to write the right R module. You only say that the R module. The M is R module. Need not to say right R module, need not to say left R module, and we only to say that M is R module. Okay? And the question one is answer, and then this is also the answer for the question two, because when case is a few, K is commutative, because a few should be a ring, a commutative ring. So the commutative ring, so when you create the vector space, you need not to say right vector space or left vector space. You need not to say here. You need not to say right vector space, left vector space, because K is commutative. K is commutative, and then we say the vector space. Okay, that is the answer of the question two. Is the vector space. We need not to say anything about this. Okay, that is the first question and the second question. Now we have the first question. Okay, so now the first question is I would like to say about the right arm module and the left arm module. But the first question is, I would like to say the relation between abelian group, vector space, ring-based identity, and module. I would like to keep anything in the whiteboard, because you know that I would like to answer the first question here. What is the relation? The question 3 is the relation between module and the abelian group. And the second is a vector space. And the third is ring-based identity. So now we have a rest about 10 minutes, okay? Can you hear me clearly? And do you have anything that is the difficulty?
No.
Not yet.
Okay, it's okay.
Yes, it's okay.
Okay. The first difficulty, the difficulty is the whiteboard is very small, so you should try to read. But I think that is you can see in the books. So I say that you should print the course, and then you can sometimes you can see in the books, because you can see in the whiteboard here is very small. Okay. For teaching mathematics, the whiteboard is the blackboard or whiteboard is very important. It should be bigger, but here that is only the machine, the computer, so that is very small. Okay, we should try. We have a rest now. Okay. Okay, we continue. um, the first I say the relation between the vector space and module. That is a very easy because okay, the vector space and the module is very easy because the vector space is the field K. That is the V and the over K. V over K here. And K is a field. And here is the M over R, and R is the rings with identity. Ring with identity. The vector space is the VK. So, okay, here. So the VK, the vector space, that is the module. That is the module. That is the module over K. Mean that that is Vk is vector, that is the module over K. Because in this case, K is the field, and then that is a ring with identity. Here. So the vector space is a module over K. But the module over R is not a vector space. Because the ring with identity is not a field. It's not a field. So a module over a ring R is not a vector space. A vector space, I say again, the vector space is a module over K. However, a module over a ring R with identity is not a vector space because a ring R with identity is not a field in general. Okay, so that is a relation between the vector space and then. So when you take an example, that is very easy if you say that, okay, that is a module. Okay, for example, here, you remember the R square. The R square is here, okay? The R square here is R, the vector space over R. So that is the module over R. The R square is module over R. Oh, here is the R power 3. You also have the that is example of module because that is few. That is few, but the vector space is module, R module, and R is commutative. So I only say that is R module. R module. Okay, here is R module because that is vector space. Vector space. So that is the first. That is the first relation. Easy. Okay, you can see immediately about the relation here. Very easy to see. The second is the abelian group. The abelian group and module. So the module is the abelian group is easy. The module is abelian group. It's easy, okay? Because if you want to define the module, you should have the first is the abelian group. So the module is abelian group. However, the abelian group, how to construct a module. And then we will construct something like this. The abelian group is a Z module. Mean that a Z module over mean that a module over Z. Z is the integer, okay? The rings of integer. How to do this? You will to do something like this. Okay, I maybe should to erase where here is okay. I see what this. Maybe I will erase here. So now I give you a abelian group. For example, I write that is A. And the operation, for example, that is, for example, plus. So the abelian group, okay, so Z module mean that you should create the Z and to tie here is not left, not right, because Z is commutative. So you should Z A. You should take a ZA with a Z in Z and A in A. So you should create the module multiplication. Okay. What is the definition here? You remember ZA is equal to the A plus A, and what is this? What is Z tie? If Z is bigger than 0. Z in Z and Z is bigger than 0. And if Z is equal to 0, and then that is equal to 0. And if Z is less than 0, so you will have a minus A, and then plus minus A, and then plus, so on, plus minus A. And what is this? What is 2 minus Z tie? So this is the definition of the ZA. You remember in group, we have a ZA is defined something like this. So you can check the 4 axiom of module. Mean that you can check Z A plus A prime is equal to ZA plus ZA prime. Z plus Z prime A is equal to Z A plus Z prime A, and Z prime A is equal to the Z prime A, and 1A is equal to A. Okay, you can check it easily. So the abelian is Z module, and the Z module is abelian group. So I have the proposition here. The first proposition is the vector space is, the first proposition is the module, the vector space VK is K module. The second is proposition 2 is an abelian group. No, maybe I will. If and only if is abelian group. If and only if is a Z module. Okay. A is abelian group and A is a Z module is the same. It's the same. So you can see that is very important. You know, that is, you can see that is the abelian group, but you can see as the Z module. And first, you can see let R be rings with identity. Then you will have RR and R. Mean that the ring R will be viewed at a right R module and also a left R module. Mean that in this case R have two roles. The first role is okay, here is MR, you see here. So the first role is M, and the second role is R. Mean that is will be have two rows. Okay, two rows. The first row is here. Mean that M is R here, and the second R here. Mean that R is R module, and R is left R module. Okay. Why? Okay, you can see here. Here is X, Z, Y, and Z here. And you remember that is in R. And here is in R. And you remember that is a two row. Here is R, here is R here. So you see as is in R here. And this is in R here. Okay? So that is the same as the module axiom. And here, the X here, and Y, Z here, you can see X is in R here, and Y and plus Z is here. Okay, and then the same for this one. And X1 is equal to X. X1 is equal to X. X here is in R. Of course, that is in R. But you remember that is R here. So R here. So you have the X1 is X. So the ring R, if you consider about the module, you will receive the RR, and the similar, if you consider the 1X is equal to X, 1X is equal to X, so you will receive the RR here. In mathematics, when you consider a set or a structure, and if you see it if you consider it, and then you receive many property. And another one, if you to change the view of point, and then you can see these objects by another views of point, you will receive many property that is very interesting. And same as in our life, if you consider one person For example, you can consider that is a student, and then you receive many things related to the student. But if you consider is a brother in the family, you will receive it in many others properties. Okay, so that is very important when you change the points of view. Okay. Tôi có thể chỗ này tôi có thể nói tiếng Việt một vài cái tôi vừa nói đó. Tức là trong toán á, thì và chính đã học toán là phải như thế, tức là ta phải nhìn một cái object, tức là một cái đối tượng dưới nhiều cái quan điểm khác nhau. Đấy. Thì khi mà nhìn nó như là một nhóm Ben á, thì ta sẽ có cả cái tính chất của nhóm Ben. Nhưng mà bây giờ khi có cái hay là nó lại là Z module, thì lại chúng ta lại áp dụng được những, nếu như khi mình đang giải toán là nó là một nhóm Ben, nhưng tự nhiên là mình có những tính chất trong module, mình áp dụng cho một cái Z module này thì nó lại trở về. Tương tự như vậy, một computer mình có thể nhìn nó như là một module, hay là một văn ta có thể nhìn nó như là một cái module phải, module trái. Thì với những cách nhìn như thế, nó sẽ thu thập được những cái tính chất khác nhau. Người ta gọi là thay đổi cái quan điểm nhìn. Và trong cuộc sống thế, ví dụ như là một cái nó cũng phải nhìn nó thay đổi. Ví dụ như khi mình đang ở nhà, mình có thể là một cái ông anh ở trong nhà chẳng hạn. Nhưng khi mình đi học chẳng hạn thì mình là một sinh viên. Đấy, thì những cái cũng là một cái object đó thôi. Nhưng mà đối với mỗi cái nơi là nó mỗi khác. Đấy, vì trong nhà mình đối xử như thế nào thì bố mẹ như thế nào, rồi mấy em như thế nào, rồi vân vân, thì nó khác. Nhưng khi mình đi học sinh viên thì mình bình đẳng với các bạn khác, rồi mình phải cố gắng học, rồi vân vân. Đấy, thì như vậy là thì với những cái cách nhìn như vậy nó sẽ ra những cái tính chất khác nhau. Để tôi muốn nói thêm một vài từ tiếng Việt về ý nghĩa triết học của cái việc mà nhìn các cái mối quan hệ là nó rất là quan trọng. Và như vậy với những cách nhìn như thế này thì các anh chị nhìn thấy rằng là rõ ràng là có những ví dụ đấy như thế. Ví dụ một không gian vector là các anh chị có thể xem như module, một nhóm Ben là các anh chị có thể xem như module nhưng mà nó là Z module, một văn có thể xem như là nó một cái module bên phải, module bên trái. Và chính cái chỗ này là chỗ khác nhau giữa bên phải bên trái đấy. Vì sau này là các anh chị sẽ học ý đi bên phải, đi bên trái là khác nhau, mà khác nhau là chính ra là nó sẽ dẫn đến là module bên phải và module bên trái là khác nhau, là vì thế đấy. Một cái module phải nó khác với module bên trái. Anh có thể có một cái module bên trái, anh có thể có module phải, nhưng hai cái nó khác nhau. Hai cái đó khác nhau. Cho nên là không phải là có module phải, có module trái thì ta cho hai cái đó bằng nhau. Chỉ it is only in the case of the ring is commutative, and other one is we cannot say that the left arrow module and right arrow module in the same. In general, that is different. That is only in the case the ring R is commutative. I emphasize that is a ring R is commutative, and then we will call it the R module. That is not right R module, not the left R module. We only call it is the R module. Okay. So we have a many. So I say that is many examples. Many examples about the okay, I can write briefly here. For example, okay, if you take the ring R is commutative, and then you take the Rx here, mean that the polynomial the polynomial and then that is a ring, and then R is commutative, and then you will receive the Rx, the Rx here. There are two. If you you say that that is a ring, and then you will Rx and Rx. Okay, and in this case that is commutative, Rx is commutative, and then you have the Rx the Rx module, and you have the F plus J and also the F tie rays. Okay, plus of two polynomials and the multiplication of two modules. You have the Rx module. However, the Rx here you can have this one, and you can take the Rx, and then the first is also the F plus ray, mean that, but the second is F tie R with R in R. This is different because here is the tie, the multiplication of two, the multiplication of F and J, but that is the multiplication of F and R. R is only one element. For example, the A0 plus A1x plus ANXN is A is in R here. If you tie with A, that is only equal to the A0A plus A1A X, so on, ANA XN. Okay, that is. And then that is a module, R module. So you should say that R module or Rx module. You should consider when you consider that is Rx module or Rx module. Okay. But similar with M tie N R, isn't it not commutative? That is equal to the A and then M R. A is in R, the matrix. And the psi here is M tie N. So that is the A11, A1N, and then AM1, AMN. Okay? And then you have the plus and the second is you tie with R in R, and then you take R inside all of the element here, entry here. So that is equal to the A, okay? And then you can check that is right R module. But if you change this is to tie the left, mean that R here, and then A here, and then you tie R this side. You will check, you will receive the left R module. And in this case, I don't take anything about the ring R is commutative, so we cannot say that the left arm rule and the right arm rule is the same. We cannot say about the right arm rule and the left arm rule is the same. That is the different in general. The different in general. Okay. However, now I change in the case m is equal to n. Okay, m is equal to n. You will have the m, n, r. Is the square matrix. Okay. In R. In R, so the first you will have the same here. That is the same. The plus is the same here. But the second, you also have this one, the same. Here is 1. 1 is the same here. That is only the A, the A and J is anti-n, anti-n. Here is anti-n. The second is the same, but that is in this case m is equal to n. M is equal to n. You have the 2 here is the same. Okay. But you remember that it's a square matrix, so you have the multiplication. Okay, you remember the multiplication? That is AJ n tie n, the B JK n tie n, that is equal to the C AK and okay, arrow is here, and the formulas is CAK is equal to the sum of J from 1 to n, A IJ, and then B JK. Ok, nhân hai ma trận vuông ha. Hai ma trận vuông, nhân hai ma trận vuông. Còn trên kia nếu như em mà nhân n thì cái ma trận nhân sau phải n nhân gì đấy mới được. Còn hai ma trận vuông thì bao giờ nhân được với nhau. Vì đó là n, còn sau này là tiếp tục n nhân n nữa thì nó sẽ ra ma trận n nhân n. Okay, so we receive the matrix, and then that is the entry of the matrix here. And the M and R here is a ring with identity. Identity here is 1, 1, and then all is a 0 here. Here is identity. We say that is En. The matrix in the diagonal is 1 and other is 0. Okay, so here is a ring with identity. So in this case, we have a study. So that you have what is the MR and R? I will area. So what is the structure of M and R? So the M and R. So you have a many structure here. The first you will consider the M and R is M and R is right R module. Okay, that is because that is the same as the case N M is equal to N. The second is the left R module, the different. But because you consider the MR is ring, so you have the MN, R, and then here is MNR, ring, and MNR, so in this case, when you take the R is a ring with 1, you have a 4 structure, module structure with MNR. With MNR here, and R is a ring with identity. You have the first one is right MNR module. MNR is right R module. Left R module. MNR is right MNR module. And MNR is left MNR module. Okay, you have a 4 student. So when you see the MNR, you should have the question, oh, what is the its structure? You should consider and then to ask what is the structure here. Okay, so I think that many examples that you can in the books I also to write many examples here, so you can read it. Okay, I stop the section 1 here, and then you will to take the exercise. I right here is the 6 homeworks. So now I will change to the sub-module and the question module. The first, we have the definition of the sub-module. Okay. Now we will let the MR. Okay, in our course, I will write the essentially write R module, and then if something related to the left module mean that the same, and then you can change the size, the reserve for the left R module. But I only say here you understand that is the right R module. And now you take the A is the subset of M. The subset of M. The question is when we will say that the A is the submodule of M. So if you want to A is the module, you should create the operation. Mean that the plus and the module multiplication. And then, okay. And then the first is the plus. The plus, of course, we also to take the plus here. And you remember that what is the plus? Plus is M tie M to M. And then you take the X here and Y here, and then you receive the X plus Y. And then I take that is plus. Here is the map. Now you take the plus and then to rext it to A. Tie A. Mean that you want to A tie A to A. Okay. But in fact, that is go to M. Go to M, not A. In fact, that is M. So you should give the condition. You want, it should be A. You want this one. Okay, because, okay, I give you one example. For example, you take the minus from Z to Z, tie Z to Z. And then you take, for example, 2, and then here's 1. So you have, that is 1. Oh, to take, for example, 3, 1 is, that is 2. Okay, you take 6 and 7, you will receive, that is minus 1. Okay. However, if you take a Z from N, write it to N, Z to N. Here is Z to N, tie N. That is go to Z, not N. Because here, for example, 6 and 7, you will receive the minus 1. Minus 1 is not belong to N. Okay? So you want, if you want operation plus, you should go to A. And that is should give the condition. For this go to A. So the condition is here. What is the condition? The condition is what is it? X in A, Y in A, and then X plus Y is in A. The condition here is the X in A, Y in A. You should have the X plus Y is in A. That is the condition. The similar with MR, here is R and then XR here. And then condition here is R, here is AR, and then we should have the AR here, so the condition here is AR. So the condition here is, so the similar is R in R, you should have a XR in A. It's R in A. You should have a two condition. If you have the A is the subset of M, and you plus two condition. And satisfy this one. satisfied here. The first condition. And when you have when you have the condition here, and then you have the operation, then A's have the operation, two operation. And then, okay, if you want to have the module, so you should, the condition here is A is a right R module. Then A is Collins, a submodule of MR, denoted by A is here. Because we use the inequality here for the distinguish, this A is here. That is mean that the not submodule. That is only the subset. And here is a submodule. And in case A is not different, is not equal to M, you write that A is here. Okay? That is mean that here is mean that A is the submodule of MR, but A is not equal to MR. Okay, the notation, okay, denotes by here. So you have a two operation, and then A is a right R module, and then A is the submodule of MR. A is a submodule. So in many cases, you should remember that A is a submodule of R, mean that the first A is have the operation, and also A is right R module. It should be right R module. Okay, right R module. Đây, có nhiều khi là rất là tức cười là còn mấy khi tôi dạy xong mà có mấy người không để ý là hỏi mô đun con là có phải là mô đun không. Đầu tiên là nó là khi mình đẻ ra là một người con thì đầu tiên nó phải là người cái đấy chứ. Rồi nó mới thỏa mãn mấy cái tính chất giống như trong gia đình mình vậy. Nó giống mặt, giống mũi, rồi giống cao, rồi nó thấp, rồi về gì đấy là cái khác, nhưng mà đầu tiên nó phải là con người cái đấy chứ. Tức là mình nói là con ở trong cái tập thể của gia đình mình thì đầu tiên nó phải là con cái đấy, phải con người cái đấy chứ. Một cái mô đun con thì đầu tiên nó phải là mô đun gì đó, mà muốn mô đun thì nó phải có hai phép toán. Vì mọi người cứ có mấy em cứ nhìn vào cái tiêu chí của nó. Bây giờ ta sẽ nói đến tiêu chuẩn, mà nhìn vào tiêu chuẩn lại không nghĩ đến nó là mô đun con, là mô đun. Okay, but by the definition here, if you want to check that is the submodule or not, is submodule or not, you will check what is here. Here is the first condition, the second condition, and then a right R module mean that H axiom, and then X condition, and then here is a two condition. So you should check a 10 condition. Oh, too much. By the definition, you should check a 10 condition. However, in fact, that is only 3 conditions. Okay, here is a 3 condition, and I will write it, and we will continue in the next. So we have the theorem that is A, let MR, and then N. A is the subset of M, and then A is the submodule of MR if and only if the first A is not equal to the empty set. The second is the condition 2, two conditions here. For every X, Y is in A, X plus A is in A, and the second is for every X in A, for every R in R, you should have the XR in R. That is only 3 conditions here. So you only to check the 3 conditions here, and then you say that the A is a submodule of MR. Okay, I would like to stop here, but I would like to ask you, do you hear me clearly, and is easy to understand, or is more difficult, or you have the you would like to say that I will change something or not, or something like this? Okay, mean that if you have any ideas, you can say to me something now. Okay, who?
Kia là nãy ở cái
you can speak Vietnamese. You can speak Vietnamese.
Là nãy cái phần trước thầy là cái chỗ mà thầy hỏi là cái liên hệ giữa cái module với lại cái abelian group của thầy. Không biết thầy, em có thấy cái này là cái cấu trúc của một cái module, em thấy nó tương tự như là một cái đồng câu nhóm, là từ một cái tích một tích của hai cái là R và M và D đến M, có thể nói đó là một từ đồng câu nhóm luôn cũng được. Em nghĩ thế, không biết đúng.
Từ đông cầu nhóm hả?
Từ đồng cấu.
Liên hệ cái nhóm Aben đó hả?
Dạ.
Trong nhóm Aben thì thì thực chất là khi mình nghĩ qua đồng cấu làm gì cho nó phức tạp nhỉ? Vì nó thực chất là nó chỉ lấy cái cấu trúc của cái phép cộng ở đó thôi chứ đồng cấu thì nó liên hệ gì chỗ này à? Thì một đồng cấu nhóm thì khi mình có x cộng y thì fx nó sẽ bằng là fx cộng fi đó. Thì phép nhân cái phép cộng đó thì gì đặc biệt đâu, mình suy nghĩ thôi được, là cứ nghĩ xem cái thứ nó liên hệ thế nào nhé. Ok, another question. Có gì về cái chuyện dạy hôm nay có trên bảng rồi nó có rõ ràng không, rồi có nhắn không, hay là như thế là tốc độ vừa phải rồi? Ai có ý kiến gì không? Lớp trưởng.
Dạ, em thấy dạy tốc độ cũng vừa, đều có nhiều đoạn em hiểu, em nghĩ là chắc em phải về đọc lại tài liệu.
Okay.
Yeah.
Okay. So, okay, I know it.
Dạ không, thế nào thế?
Đấy, có ai có ý kiến gì nữa không? Vừa rồi là Minh mới hỏi phải không? Hay là ai vậy?
Dạ, em ạ.
Okay. Okay, if you have any question, we will continue in the next week. Okay, see you next week.